All right, it's my pleasure to introduce our second speaker today, Meg McEachran. She's a PhD candidate in the Conservation Sciences program at the University of Minnesota and in my lab. She's interested in applying interdisciplinary approaches to solve natural resource issues, including invasive species and wildlife disease. Take it away, Meg.
Thank you, Nick, for having me, and thank you everyone for being here. Some of you may have seen some of this work, but we have some updated results and stuff that I'm excited to share with you today. The title of my talk is Assessing the Risk of Fish Pathogen Introduction via the Illegal Release of Live Bait Fish in Minnesota. And as Nick mentioned, he's my advisor, and this was carried out at the Minnesota Aquatic Invasive Species Research Center here at the University of Minnesota. And like any project, we have a massive number of funders and partners, including partners at the State Department of Natural Resources, USGS, several departments and colleges across the university, and our funding from the Environment and Natural Resources Trust Fund. So thank you to those folks listed there. So in order to contextualize this work, I like to think about how the rapidly expanding trade in live animals for purposes of bait or food or pets has facilitated the spread of invasive species, and in particular, invasive pathogens that can be a major threat to conservation. Of course, one of the more infamous examples of this is the Cytrid fungus that spread via the live amphibian trade. And pathogens can be particularly difficult because they can pass undetected in otherwise apparently healthy or innocuous species, but cause devastating impacts when they infect a vulnerable population. And this is not just a global phenomenon that's taking place all over the world. This is happening right here in the Midwest in our backyard in Minnesota, where I work. Live bait fish are really important to Minnesota's local economies, as well as our very popular recreational fishing industry. And for those that are not familiar with the live bait fish pathway in Minnesota, or maybe at all, most of our live bait fish are harvested from wild sources. About 60% is coming from the wild, usually in shallow, high productivity lakes where the fish are raised. They're then harvested or brought. Sometimes they're raised in aquaculture. That's about 40% of the source. And then they're taken to wholesalers or maybe straight to retailers where they're sold to retail recreational anglers. That's only about half of the pathway though. Once the anglers take possession, they then are going to take the fish to their destination fishing, whether that's a lake or a river close to their house or close to that shop, or whether that's a long distance across the state. So each step in this pathway represents opportunities for pathogen spread. At the point of the source, there's millions of individual fish that get either produced or harvested every year, and there's minimal disease testing, and in some cases, no disease testing, and very low biosecurity, particularly for those wild sources. Additionally, we have low traceability of those shipments. It's really difficult to keep track of where they're going and whether or not they're mixing with other shipments. At the point of the anglers, we have an example of a highly complex and distributed risk in that there are millions of individual people making those decisions, buying those fish and moving them across the landscape every single day of the fishing season, and they're highly transient and dynamic. And finally, we have thousands of lakes, each with a different risk profile in terms of susceptibility to introduction of disease, and we have that angler taking them and potentially accidentally or deliberately releasing them into the water. In Minnesota, it's illegal to release live bait fish into the water, but one of the open questions of this project was, how often is that actually occurring, and what could that mean for risk of fish pathogen introduction? So altogether, these factors result in a potential pathway for the spread of fish pathogens. Combine that with the fact that there is a perceived or perhaps actual shortage and difficulty in finding appropriate bait, and anglers' demand for safe, reliable bait supply is increasing. And we've got this big tangled mess. So the purpose of my project is to understand the risk of fish pathogen spread via the illegal release of live bait fish by recreational anglers in Minnesota. When thinking about risk, it's important to break it down into manageable steps, and that's exactly what we did. So in order for a pathogen to spread along the bait fish pathway, a series of steps must occur. First, that pathogen has to occur in live bait fish. Of course, there are other pathways that exist for pathogen spread, but for the purposes of this project, we're focused on bait fish. Second, an angler has to purchase those bait fish, and finally take them to their destination water body where they release them into the water. I always get asked this question, so I'm just going to answer it now before it comes up later. Yes, there is risk of incidental spread just via the use of live bait fish, but actually physically releasing large numbers of live fish, their leftover bait fish, into the water infected with a pathogen presents a much greater risk than just transmission via ingestion or just incidental contact with a fish in the water. It's also illegal, like I mentioned. So again, for the purposes of this project, we focus specifically on release behavior. So breaking that down into 3 questions, we find, what are the hazards of greatest concern? What are the frequency of risky behaviors that allow the pathogens to propagate along the pathway? And what is the risk of fish pathogens spreading to wild fish in Minnesota? So in order to answer this first question, we have to understand what the pathogens are out there that we're dealing with. I don't have to explain to this crowd that fish have hundreds, if not thousands, of commensal microbes living in, on, and around them at all times, and not all of them cause disease. We know that some pathogens and invasive species have been found in golden shiners in Minnesota via a statewide survey we did a couple of years ago, as well as a number of non-target species, so non-shiner species being sold as shiners, as well as a lot of novel viruses. So there's a lot of things out there that we could be concerned about, and that can be really overwhelming for managers. So we have to understand the continuum between risk tolerance and risk aversion and how to strike the right balance in terms of managing our disease risk. Right now, the sort of typical approach is the precautionary principle, whereby novel or uncertain pathogens are automatically prioritized and given resources and risk management efforts. On the other end of the spectrum, though, is a more risk tolerant approach where you might manage outbreaks as they occur. Both of these have their pros and cons. Regulations can be burdensome and use up valuable resources, while a more laissez-faire approach can risk disease outbreaks. So the purpose of this part of the project was to help strike a balance. And in order to do that, we developed an evidence-based hazard prioritization framework to identify and target the most hazardous pathogens and balance the benefits of live bait fish use with the risks that it could be a pathway for the spread of invasive species. In order to do this, we created a screening framework first to just filter out any pathogens we weren't interested in understanding further for this pathway. So all fish pathogens are narrowed to just pathogens that can cause disease in Minnesota fishes, that can be transmitted by live bait fish, and that resulted in a list of 15 potential hazards of concern. We then created 7 weighted criteria and scored them on each of these criteria and ranked them according to their total weighted risk score. The likelihood of transfer in bait fish, the prevalence in bait fish, the pathogen's current distribution in Minnesota, their potential to colonize Minnesota waters, if not here already, the host species that they infect, and their ecological and economic impacts if established. Using this weighted risk score equation, we then calculated the total weighted risk score for each pathogen. And this is what we found. On the left side here, we have the risk versus uncertainty. So we also graphed the sort of degree of uncertainty associated with each of these pathogens, because as many of you know, some research about fish pathogens is very scarce. We found that there were 3 pathogens that kind of emerged as our top riskiest ones: Asian fish tapeworm, Ovipliostaphra ovariae, and viral hemorrhagic septicemia virus. So for the purposes of time, I'm going to focus just on VHS through the rest of this talk, but keep in mind that we're doing the same things with Asian fish tapeworm and OVO as we go through. So we have to understand that in terms of making management decisions, it's not just a consideration of risk. We also have to consider resources and time and priorities and risk tolerance and our uncertainty. How much uncertainty are you willing to tolerate in your estimates? So we created this figure to help explain that kind of relationship between uncertainty and risk and help support decision-making by fish health managers when they're deciding how to prioritize these pathogens in live bait fish. So we did the first step. We identified the hazards of greatest concern. Now we need to understand the frequency of risky behaviors that allow these pathogens to spread. For the purposes of this project, we're focusing on the angler-mediated steps. Yes, there are steps in the pathway prior to the retail store, but we're focusing primarily on anglers for this project, for the main reason being that they number in the millions. The other reason being that they are known, or there was a suspicion that there was some illegal activity and release behavior happening. And I'll tell you about what we found in a bit. So in order to understand what behaviors we need to quantify, we need to come up with a conceptual framework to understand where the risky steps are. In order for a fish infected with a priority pathogen to be released, that angler has to use live bait fish, they have to purchase susceptible fish, purchase a fish that's actually infected, and then release that infected fish into the water. And if all of those steps occur, we're considering that a risky trip, or a trip that results in the release of a pathogen of interest. So we did a survey of resident and non-resident annual license holders in the state and got about 670 responses to that survey. We found that a majority of anglers, are using live bait fish, with about 70% reporting that they use live bait fish when they fish in Minnesota. And a huge majority of those are purchasing them. There were, I think, fewer than 30 that reported self-harvest, but they do exist. We also wanted to drill into where they were sourcing their live bait fish. So we quantified the probability of purchasing or harvesting live bait fish from this Lake Superior watershed up here outlined in red. We'll come back to that in a little bit, but only about 6% of anglers are getting fish from that region. Next, we had to understand the probability of using fish that were susceptible to our pathogens. Again, we went through and did this for OVO and AFT as well, but I'm going to focus on VHS for now. So we found that about 22% of anglers purchased susceptible shiner species, and about 75% of anglers purchased fathead minnows, which under international fish health guidelines are considered susceptible to VHS. We found that although a majority of anglers reported properly disposing of their bait, either in the trash or taking it home to compost, about 20% admitted that they released it in the water. And actually in another smaller scale survey that we did, we found that about 30% did. So release in water is unfortunately common in the state. And this was true both for harvesters and for purchasers. We also quantified the number of trips per angler per year, and we found that there was no association between the number of trips an angler took per year and their likelihood or propensity to release. So this is a fairly widespread behavior, and it occurs at equal rates across the state. Next, we had to come up with a hypothetical probability of infection with our pathogen of interest, which is VHS. Currently in Minnesota, inland lakes have not been known to be positive for VHS. Technically, Lake Superior is considered a positive water body, and the state has a rigorous testing regimen that has been implemented for the past 10 plus years. But we wanted to understand what is the possibility that some VHS could be introduced and begin spreading without our knowledge. Given the testing regimen, we found that you are almost certain to detect Vhsv at about 60% pathogen prevalence. And even at a lower prevalence, around 11%, you're probably going to detect it. But at a very low pathogen prevalence of about 1%, you're only about 50% likely to detect that using the standard AFS Blue Book recommended sampling procedures. So we allowed this probability distribution to describe the likelihood of Vhsv presence in the live bait fish of interest. So we calculated and quantified the frequency of risky behaviors that could allow the pathogen to spread along the pathway. So finally, we have to put it all together and quantify the risk of fish pathogens actually spreading to wild fish of interest. So going back to our risk pathway, remember an angler has to do each of these steps in order for a risky trip to occur. And we can assign a probability of each of these steps occurring based on the data we got from our angler survey. And when you multiply these together, you get the probability of all of these steps occurring. Then we can actually iterate over this calculation hundreds of thousands of times and calculate the number of times the model results in a risky trip. So again, if any one of these columns is a 0, that means that step is not occurring and the trip is not risky. However, if all of them have a 1 in them, we can get a risky trip. And so we actually iterate over this calculation millions of times to construct a probability distribution that describes the likelihood of that number of risky trips occurring. So for our model inputs, we have all the probabilities of the various steps in the pathway based on our angler survey and historical license data. And then we can also understand, based on our model, the probability of at least one VHS fish release occurring in a given year, the probability of any single trip being risky, and the number of risky trips occurring in a given year under various model conditions. So when defining those model conditions, we modulated two different factors. One was the actual species that we allowed to be susceptible to VHS. Currently in Minnesota, although I think pending some changes, I actually would like to hear from some of you about this coming up. Currently in Minnesota, there are only 2 Shiner species listed on the former USDA AFS Vhsv susceptibles list. And so those are the ones tested for VHS in the state. But we also wanted to consider a set of models where fathead minnows were also allowed to be susceptible to VHS. Second, we modeled the effect of the location of the outbreak. Remember, I mentioned this higher risk watershed up here adjacent to Lake Superior. When we wanted to test whether or not the kind of extent of the outbreak mattered with respect to risk. So was the outbreak contained just to this zone 3 or was it statewide? So that resulted in 2 factors with 2 levels, 4 different models we were testing. Here's our results. On the x-axis is the number of risky trips that are occurring per year. And on the y is the number of model iterations that resulted in that number of trips. So the higher the bar, the more likely or the more times the model predicted that number of risky trips to occur. So in our model iteration where the outbreak was confined just to the zone 3 or that Lake Superior watershed with just the currently tested species, over 99% of risk of trips were not, or excuse me, over 99% of model iterations had no risky trips. So that's awesome. Fewer than 0.2% of model iterations predicted any risky trips. That goes up just a little bit when we increase the the fish species that can be susceptible to include fathead minnows, but still pretty low probability of any risky trips occurring. However, when we expand to statewide, the number jumps to about 160,000 risky trips on average, and a whopping 680,000 risky trips on average occurring when the outbreak was allowed to occur statewide in all susceptible fish. We can debate about the number or the likelihood of each of these scenarios occurring, but I just want to illustrate that the model is very sensitive to the different parameters that you change. And that's what I want to illustrate here as well. So this is a sensitivity graph. The middle line illustrates the baseline or the mean value of trips. And then to the right is an increase in that value, increase in the number of trips as a result of changing that input variable. And to the left is a decrease based on that. So as you can see, the probability of using live bait fish is the most influential variable when the outbreak is confined just to Shiner species in the statewide, with the probability of releasing live bait fish coming second. However, when we included fathead minnows in those fish that were allowed to be susceptible, the probability of releasing live bait fish becomes by far the most important variable in predicting that number of risky trips. So bottom line is, it's really important to understand what your susceptible species are and what behaviors are actually driving that risk. So we have good news and bad news. The good news is the majority of anglers do not release their live bait fish. The vast majority in most scenarios are not likely to be risky, and a vast majority of model iterations had no risky trips occurring. Under current conditions, the release of Vhsv positive fish is unlikely. And increased access to safe, reliable bait can reduce the risk of OVO positive and other positive fish. I didn't show those results today, but I'm happy to talk about those as well at some point. However, there's bad news as well. Given gaps in our current management framework and the highly dynamic nature of the live bait fish pathway, release of Vhsv, OVO, or AFT positive fish is possible. And angler release behavior is relatively common and drives that introduction risk. So we actually answered our final question as well. What is the risk of fish pathogens spreading to wild fish in Minnesota? So in conclusion and moving into the future, pathogens of concern can and do occur and spread via live bait fish in Minnesota. Angler release behavior presents a critical weakness in our pathogen prevention efforts and should be a focus of future management. We also need to have a discussion about our acceptable level of risk and what degree of risk associated with live bait fish is too much before we say we need to consider alternative options when the industry presents such an enormous benefit to the state. And finally, reducing pathogen introduction risk via behavior change, ensuring clean live bait fish supply, and increased vigilance for pathogens of import are is very possible and very important. My current project that I'm working on now is assessing the motivations for illegal release to understand how we might be able to change angler behavior and recruit them instead in prevention efforts rather than increasing that risk, as well as talking with bait fish retailers about the impacts of potential regulation changes on their business. And with that, I would be happy to take any questions, and thank you again for having me.
All right, thank you, Meg. Excellent presentation. Feel free to drop questions into the chat box or unmute yourself and ask Meg directly.
I guess I can start. Hi, my name is Gary Marty. I have a question. I might have missed it, but how common is Vhsv in any of the bait fish species in Minnesota right now?
It's not found in them right now. Minnesota is not considered, at least the inland lakes are not considered VHS positive. It's never been detected in, again, I think 10 plus years of testing. And we're actually about to adjust the testing regime to reflect that kind of lower risk existence. The reason we allowed it to occur is sort of a worst case scenario if it were to be introduced. I didn't show this, but we do have documented examples of anglers bringing in fish from out of state. It is illegal, but they do it. So to allow kind of for a worst case scenario model and showing what could happen if it were to get into the supply is why we allowed it to occur in some of those models.
Okay, so the actual risk is very low if you don't have your pathogen in your fish that are being transferred. So thanks.
Right. Yeah, it's zero basically, but that uncertainty about whether or not it's actually there is the kind of the issue.
Dr. Winton?
Thanks, Meg. That was interesting. My memory may be wrong, but I seem to recall that when VHS first was found in Great Lakes, that Ontario commissioned a similar survey with a graduate student that found numbers that are similar to yours in a way, that about 40% of the anglers admitted to releasing bait fish. And because anglers are notorious liars, that's probably an underestimate. But then there was also a significant fraction that gave them to other anglers, and you found that as well. And presumably 40% of those then released their bait fish as well. So the actual number of bait fish being released is probably pretty high. What do you think the goal of a bait fish inspection program or having aquaculture bait fish of certified origins would do for these kinds of threats?
Yeah, I think it's very promising because in some ways it's an easier group to manage. These are a group that's already, getting licenses and going through testing, maybe, and, going through the process, and they might be more inclined to, comply with things like that, while anglers might be more casual. Maybe they just got a day license or a weekend license. I do think, though, that it's sort of a huge untapped potential risk reduction because a lot of people just don't even know it's illegal. So I think just some of those really basic awareness campaigns would probably get us a lot of bang for our buck. But I think a bait certification kind of in conjunction with angler education could be really powerful in reducing risk.
Yeah, Andy Goodwin in Arkansas set up a program that I think began looking at bait fish certification programs and got quite a bit of traction with it. But as you say, at least informing people so that they're not harvesting bait fish from the wild or buying them from uncertified sources or at least unknown sources would be very useful.
Yeah, that's another kind of thing we're adding this summer is understanding how bait fish retailers would feel about something like that and whether or not, just understanding some more of the dimensions of their attitudes towards that kind of thing so we can start to move in that direction.
Right. Thank you.
Thank you.
All right, Esteban?
Hi, good morning, everyone. My question was associated with in the risk assessment that you talk about susceptibility that the fish being tested, needs to be known. What is the susceptibility for the pathogen for the pathogen in question? In this case, Vhsv. How are you assessing that susceptibility? Do you have to have evidence of susceptibility by life control challenges, to that organism that, brings its, difficulties already depending on the organism, or you're assessing it by outbreaks known in natural situations, or are you assessing susceptibility by actually dying from the disease, getting sick, clinical signs and dying, or being able to just carry it by, and then the carrier, how was it assessed, by PCR or by cell culture? So what do you need, in order to input susceptibility for a particular species?
Yeah, good question. For the pathogens that we assess that are listed under OIE, so like internationally regulated pathogens, we go with the OIE definition of susceptibility via either an outbreak, like you mentioned, or natural infection routes. So we didn't consider IP injection evidence of susceptibility in this case. And we did not, for the bait fish, distinguish between a clinical manifestation of the disease versus just simply carrier status, because these in some ways we're not interested in the clinical signs of the live bait fish, just their ability to host the pathogen as they move through the pathway. For OVO, we went with, I think for the most part, just PCR positive. So only golden shiners were considered susceptible to that. And Asian fish tapeworm, that was a combination of PCR and microscopic identification. So it depends on the pathogen, but we considered only natural infection pathways in the lab or natural outbreaks as evidence of susceptibility in this case.
Excellent, thank you. I mean, it's just, and again, I don't think it's an easy question to answer, because again, talking about natural routes in the lab, there's not such thing as a natural route in the lab other than maybe cohabitation, because even like immersion or oral challenges, typically we are using a pretty high load. And I mean, as we heard in our previous chat, even for pathogens well known as columnaris and cycrophyllum, it's really unknown what is the load even in the water during an outbreaks. So for a lot of these viruses, even that getting enough of the viruses, to do a challenge, it's always tricky, and you have to to go back into IP injections, so it's complicated, but really, and I know the definition of the OIE, but it's tricky, because realistically, even some markets are being closed, because someone reports a PCR positive in one species, and then oh yeah, they say that it is susceptible, and then all goes down south. But anyhow, thank you, great talk.
Thank you. Yeah, this is that question of uncertainty, right? And why we included that in this dimension, because you have to make that calculation and decide whether that one species being infected is worth, potentially shutting down the trade or whatever. So yeah, thank you for your question. Very interesting.
All right, we got time for one more, and your hand's up, Tom.
Yeah, Meg, awesome talk as always. Really enjoyed it. I'm curious, as you're doing the analysis with the Asian fish tapeworm, I'm wondering, so how are you accounting for, like, does this assessment account for the need for an invertebrate host, like the difference in transmission? So, on one hand with VHS, you have that like direct transmission. And then with Asian fish tapeworm, you have more of, you also need to presume or have that intermediate host, I guess, for something else to get infected. So just wondering how you all are approaching that.
Yeah, the end outcome that we're assessing in the risk assessment, the actual quantitative component, is introductions. So I don't consider whether or not an introduction results in an outbreak. It's just the number of fish, with the assumption that, the higher the number of diseased fish being introduced, the more likely an outbreak is to occur. That being said, one of our kind of screening questions is the potential for colonization once they get here, and that kind of thing was taken into account. Do we have native or introduced species of intermediate hosts that could be hosts for the pathogen? Yes. So things like that are taken into account at this step, but they're not taken into account in the quantitative model.
Awesome, thank you.
Thank you.
All right, thank you very much, Meg. Virtual round of applause to you.